Welcome back to the shop. This is part 4 on my Toolpost grinder. As you can see, I did some work off camera. I machined a pulley, I made a belt guard out of 0.8mm sheet metal, and also I made this round belt. What I also did is I made a cover for the back of the motor that holds a switch and a lamp that shows power supply. And also I got a power supply, a 12 volt, 13 amps, Meanwell power supply, and I hooked it up to the motor and everything's running. And as you can hear, it runs pretty smooth. With this setting I got 10,000 RPM on the motor, on the spindle. And I can also change over the belt to the bigger pulley on the spindle. And this gives me about 6,000 RPM on the spindle. Now I'm going to show how I made this belt. This is a pretty simple process. To weld the round belt, I'm going to heat up both ends on the propane torch, and then I'm going to press it together and wait until it's cooled down. Hold it until it's all the way cooled down, or you will get a crimp or wrinkled section in the belt, and that will make a pretty annoying noise every time it goes around a pulley, and also it can induce vibrations or harmonics into your grinder. So try to make this as straight as possible. You can use a single edge razor blade to press down the weld. When you're doing this with the razor blade, don't try to cut in a straight line. You need to push and pull, like you need to do kind of shearing action, or you will just push the rubber or the polyurethane around. Just slice it, then you can clean up the weld until you're happy with it, and you have a pretty strong bond in this area where we weld. We have it one nice belt. Okay, and to show you that our freshly made belt will hold up, I'm going to push it over the motor pulley. It's nice and tight, and it runs fine. This is the high setting with 10,000 RPM on the spindle, and I'm going to put it over on the bigger spindle pulley. That gives me about 6,000 RPM. Okay, I'm just going to show you how this sets up. I'm going to remove the belt, take off the pulley. It's clamped on the motor shaft with a single set screw, and the drive shaft of the motor has a dimple in it where the set screw engages. I turned this pulley from a bigger timing belt pulley. I put a boss in it, glued it in with Loctite, and machined the whole pulley on the outside over. And then I cut the groove for the 4mm belt in it. And now I'm going to remove the motor mount. going to machine a slot along this direction in the shaft, in the hardened shaft, which will prevent this motor bracket, which will get a pin right here that will engage the slot and hinders it to rotate on the shaft. Okay, this is my setup to machine the slot in my round bar. I clamp the spindle holder down on this side with a strap clamp and hold the center of the shaft in my grinding vise. The left side is supported by this screw jack, which needs some tightening. I have a 4mm 3-flue carbide end mill, a regrind in a end mill holder, and now I'm going to take a first cut. Okay, now I got a nice loose fit on a 4mm gauge block. I don't want a close fit on this slot because there will just be a pin riding along, and I don't want to bind it up all the time when there's grinding dust or something else in it. So I'm going for a loose fit. Okay, after milling the slot into my hardened rod, I drilled and reamed a 4mm hole into my motor holder and pressed in a short dowel pin. You might see it right in here. There is the dowel pin inside, and that dowel pin engages the slot in the rod. So you can pull it on, but it hinders it to rotate. And in that way the motor mount is always aligned in the right way to the spindle. I'm almost finished, but there are some things I want to add. I want to make this block that clamps the whole assembly on my top slide of the lathe to look a bit better, so I'm going to cut away all this material all around the mounting hole, except for a round bearing surface. Just cut it down by maybe 0.5 millimeters or even 1 millimeter, just to give it some profile. I will do this on the lathe. I will clamp this part on the magnetic chuck and just face the material away. Okay, I'm over at the lathe and I have already put on my magnetic chuck. I put a series of concentric rings onto it with a Sharpie so I can rough align my part. I'm centering on the bore in the middle, so I'm just eyeballing through the hole onto my drawn rings. If you don't engage the magnetic chuck full, you can still tap the part around very easy with a copper drift and indicate it that way like you would on a faceplate. And when you're done, you just engage the magnet full. Now you can't take a 2mm facing cut, but you can always take maybe 2 or 3/10 of a millimeter. So let's try this. I just want a bearing surface in the center, so I'm leaving, as I'm making full contact all around now. That's good enough. I'm taking another cut just to pull it back a bit more. Okay, that's it. That's enough to give the surfaces some clearance. I only want to bear on this ring surface, so that's all I need. I can retract my tool and unclamp my magnetic chuck. So here we go. Okay, I think I finished all the parts. What I did is I contoured this all around. I chamfered the clamping block and I added a brass washer type thing that's pressed into the bracket to eliminate the need for a separate. Get everything cleaned up with 400 grit emery paper. I'm going to assemble it. I will begin with the spindle holder. On there goes the motor mount, which will get a clamping screw down here. I will not clamp this in place because I still have to mount the motor and tension the belt. On goes the motor. Then there comes the belt guard. I was asked how I made the belt guard because of this small flange all around. I did not form this out of a piece of sheet metal. I welded it from a backplate, the rim on the circumflex, and this flange is also a narrow strip that's TIG welded all around. So I'm not really a sheet metal guy, so I welded everything up. This goes onto the motor mount and indexes with 2 pins. And it's clamped by a single set screw on the shaft of the motor. Now the spindle just goes into the holder and is indexed by this pin. It's held in position by this brass thumb screw. That's it. Now the belt goes over these, the pulley of the spindle and over the motor pulley. And that's it. Now tightening the belt just by pulling the motor back until it's reasonably tight and clamp the motor in place. That's it. That's my setup for my Toolpost grinder. Okay, I already covered the bed ways of the lathe with shop towels. I wetted the shop towels slightly with WD-40 so it catches the grit from the grinding. The grit doesn't fly all around in the shop. And now I'm going to set up the Toolpost grinder. I already removed the Toolpost, and here we go for the Toolpost grinder. Okay, I just put it on and rough dialed it in so it's in line with the spindle and it's in that direction, not tilted. I'm going to wrap a rag around my top slide because the sliding surfaces on the front are exposed. Now we need to dress the wheel. I have a V-block and my single point diamond, and I'm going to put these onto my magnetic chuck on the lathe. And I'm using this setup to dress my wheel. I'm going to run the grinding stone across the diamond, and also I will hold the vacuum cleaner below it to collect most of the dust from the dressing. Okay, now I got a nice dressed wheel and the surface is also in line with the ways. What I'm going also to do is to relieve the back of the grinding wheel. Okay, now you can see I have a step in my grinding wheel. The back here is relieved and that's the dressing. I'm going to remove my diamond. Okay, I find the test piece. This is the inner race of a old ball bearing and it already has a relief in the center. Okay, let's measure this actually. This bearing race has a diameter of pretty exactly 16.5 millimeters. pretty exact, 16.5 minus a few thousandths of a millimeter. We're going to reduce this to 16.4 and just try to hit our number and get a decent finish. I'm going to set it up on my magnetic chuck. Setting up a part on the magnetic chuck is pretty easy. You just engage the chuck halfway, so you have a slight amount of holding power, and then you put your dial indicator onto the part. Okay, this is the low spot, we're tapping. Okay. For a test, that's more than good enough. That's below 1/100th of a millimeter. Okay, indicating is done. But we will see. Let's run the lathe. Turn on the grinding spindle. Of course, we want the high speed, 10,000 RPM. That's better. And that's the phone. Okay. That was the phone. Back to the machine. Okay, and we have contact with the and I just took a very light pass, and now I'm going to check the surface finish. As you can see, the surface finish is really very nice. I did test grinding earlier and I didn't get a finish that was that nice. In the first try I didn't dress the wheel that good, and also I checked the play on the spindle bearings on my lathe and I just tightened them by a hair. So everything runs now very, very tight and very smooth. So let's pull off some material. Okay. Somebody asked me why I went through all the troubles with making this grinder and said I could just strap or C-clamp a Dremel tool to my tool post. And this surface finish is the reason why I went through all this trouble in making this. This surface finish would not be possible with a Dremel-like tool or a die grinder on the tool post. I'm going to pull it off and measure it for final. This side is where I ground it, and this side is where the manufacturer of the bearing grounded. So there is a difference, yes, but this is not too shabby for my cobbled together setup in the home shop. I'm very happy with it, and the fact that I can hit a number pretty precise is not too bad. Okay, as you saw, this little setup with the engraving spindle used as a tool post grinder is pretty capable, and I think the setup will fulfill all my cylindrical grinding needs. And also, when I tilt the top slide, I can do conical shapes like on collets and internal internal tapers of spindles and stuff like that, so this widens the range of work I can do in my shop very, very wide. So thank you for watching this pretty long series of videos on this Toolpost grinder, and I hope I didn't bore you too much with details, and I have some work left to do. I will make an encasement for the power supply and also make a wooden box to store all the components, and also make a few more pulleys, but I don't think I need to make a video on this stuff. So on the video side, the Toolpost grinder is pretty much finished. Thank you for watching, and leave me a comment if you want.